Good morning, ladies and gentlemen. This is Sarel van Greden, and I'm coming to you from a very, very cold Rustenburg. Such a chilly morning this morning, but I've got my beanie on, I've got my hands warmed up, and I'm ready to go with Euclidean geometry. In this specific video, I want to welcome you to the most amazing section of work, Euclidean geometry. I know most of you don't agree with me, and that's mostly because Euclidean geometry can be really tough work. So join me in this next 2, 3, 4 videos where I'm going to go through the Euclidean geometry section of the November 2021 Department of Basic Education exam. When we look at this first question, it's actually a relatively straightforward question. Now, I love this. It's a 5 mark that you can easily get. So try it yourself first. Make sure you get it. And if you are struggling somewhere or you're done and you want to check your answers, then watch the rest of this video. So hit the pause button, try it yourself. When I look at this question, Euclidean geometry, the most important part of Euclidean geometry is what I like to call mining, as in digging, delving for information. When we look at this kind of sum, I look at the information and I'm going to teach you how to analyze this. If you haven't watched some of my other videos where I go through the theory of grade 8 to 11 Euclidean geometry, I encourage you, go back to that, make sure you know your information, then you get back to this video. So in the diagram, PQRS is a cyclic quad. So I love to think then about theorem 4, 5, and 6, my cyclic quad theorems. First of all, when I think about theorem 4, I need either a bow tie or some people call it a butterfly, but there is no connection between the Q and S or P and R. I need those diagonals. There aren't any diagonals, so I'm not going to use theorem 4. Theorem 5 says that the opposite angles must add up to 180. They are supplementary. That I can use because if Q is 93, then S1 is 87. Now, please don't just rush through this. Think about all the different possibilities. I can work with P and R1 as well. P and R1 also are supplementary. P and R are supplementary. R1, not the whole of R, sorry, just R1. Let me just make my terminology right there. So I have now used theorem 5. Now theorem 6 says the exterior angle, so angle S2 and S3, must equate to angle Q. What I love to tell my students is, how do I spot an exterior angle? Think about it as a flag. So there's my flag, the outside part. Okay? So in other words, is then S2 and S3, are they an exterior angle? Do they form an exterior angle of this cyclic quad? Yes, because PSW is a straight line. It has to be a straight line. Okay? So when we now go further, we read through more information. TR and TS are tangents to the circle. So I think about theorem 7, 8, 9. Look at the way that I break my theorems into the different sections. I read words, I think about certain theorems. So theorem 7 says that I need radii, but I don't have a center of a circle, so I can't begin to think about theorem 7. Then I go over to theorem 8. Theorem 8 says I need two tangents from a point. Do I have two tangents from a point? Yes, I do. TS and TR, they are equal to one another. But please don't forget about the theorems you got taught in grade 8, 9, and 10. If I see an isosceles triangle, S2 and R2 must be the same. Don't forget about that. Write it in on your sketch. Okay, let's have a look now at Theorem 9. Theorem 9 says I need a tangent, so TS, and it goes to R, but that R doesn't connect to P. So I can't really use Theorem 9 at all. It doesn't form that triangle that we are looking for Theorem 9. Remember the triangle we use for Theorem 9? There's no triangle there. So I'm not going to use Theorem 9 at all. But I must not forget about grade 8, 9, and 10. In an isosceles triangle, well, in any triangle, ladies and gentlemen, I can calculate S2 and R2 actually because the interior angles add up to 180. Now I've gotten all the information that I can. I cannot use theorem 1, 2, or 3 of your grade 11 theory. Why? Because I don't have centers of a circle. So I can't even use radii. So there's nothing to be used there. Let's now go over to the actual questions. The actual questions, 9.1 says, give a reason why ST is equal to TR. Man, that's simple. It's tangents from the same point. You've got two tangents touching the circle from the same point. As easy and as simple as that. Now, let's have a look at 9.2. Calculate, given reasons, the size of S2. Do not forget what we did earlier. In the previous sum, 9.1, remember that we have that ST is equal to TR. If I look back at all of those theorems I used, what do I know about S2? Well, S2 is equal to R2. Angles opposite equal sides. Now, ladies and gents, if you are in an IEB school, they are not so hectic on your reasons. Okay, they are not so hectic on the reasons. So if you say for the IEB isosceles triangles, they'll mark it right. But in the government schools, you have to use the right reason. You have to say angles are opposite equal sides. You don't want to lose that mark because you have your reason wrong. If you are unsure about what the right reasons are, then I'm going to make sure as part of this set of videos to upload onto our platform a 2-page document which is all the acceptable reasons for the government schools. I'm going to do both the Afrikaans and the English so that you've got it available for yourself, okay? So please make sure you download it and you memorize those reasons. So let's now go further and say, well, just because I don't always like to work with S2s and R2s, I like to work with X's, I'm going to choose to make S2X, which means X plus angle T must add up to 180 because of interior angles of a triangle. But angle T is 78 degrees. I'm now going to solve X. Therefore, if I subtract 78 on both sides, I've got 2x equal to 102 degrees. Dividing by 2 on both sides, x is 51. I've got S2 because remember, x is the same as S2. Now, I love to use x in this case simply because I know most of my students are more comfortable using x than S2. You don't have to use it. You can use S2. That's perfectly fine. But I believe that if you can make life easier for yourself by sometimes using the K method. That's just my opinion, ladies and gents. Follow your own method as long as you get to that answer. Let's look at the next question. Okay? Now, before I go over to the next question, I'm actually going to write in the 51 degrees that I just received. Okay? I love to do that because I don't actually know where that 51 degrees might lead me in future. So when we look at angle S3, I know some of you are just going to go, whoa, so it's 42. But I want you to tell you, I want to share with you my thinking, my way of solving these kind of sums. I ask myself from the beginning, don't I have something to do with S3? Don't I have an angle to do with S3? Yes, I've got something to do with S2 and S3. Okay? But S2 and S3, what did that relate to? It related to Q. So I'm going to now plot the path for the examiner because the examiner needs to understand the path you are walking on. So first of all, I'm going to say angle Q is equal to S2 and S3. Why is that? Because of exterior angle of a cyclic quad. Okay? Very, very, very important. Now I'm going to substitute my values in, and I'm going to subtract 51 to solve S3, and S3 is 42 degrees. Now you might come and say, oh sir, do I really have to write all of this? No, you don't. You don't. But I encourage you, at least as you are preparing for your exams, to write down as much as you can when you prepare, so you make sure that you understand the work easy and straightforward. Wow, what a first video about Euclidean geometry. I know this was an easy sum, but I want you to get into my thinking, get into the way I solve problems, because I'm going to use exactly the same methodologies going forward. So tune in to my next video where I'm going to tackle a bit more of a tricky question in question 10, and then the beautiful question in the exam, question 11. So have an amazing rest of your day. Keep yourself safe, keep yourself warm, and I'm looking forward to seeing you all in the next video. This is Mr. Van Greene and Mr. VG signing out. Keep well. Cheers.